Today we're going to be looking at a reaction, and the above reaction is performed using 100 grams of C2H3Br3 and 40 grams of oxygen. We want to determine the limiting reactant, how many moles of the excess reactant will be left over, and find how many moles of each product will be formed, as well as the grams of Br2 formed. So we know that the molar mass of our C2H3Br3 is 266.7 grams per mole. So what we want to start off by doing is figuring out how many moles of O2 we're going to use to react all of our C2H3Br3. So we have 100 grams of C2H3Br3. We need to get this to moles so we can use our stoichiometry. So this is where our molar mass comes in. And then we know from our above reaction that for every 4 moles of C2H3Br3, we have 11 moles of O2 we're using. This is 4 moles of C2H3Br3 per 11 moles of O2. And so what this tells us is that in order to fully react our C2H3Br3, we would need to have 1.03 moles of O2. Well, how many moles of O2 do we actually have? We know that we had 40.0 grams. The molar mass of oxygen is 32.00 grams per 1 mole. And so we know that we have 1.25 moles of oxygen. So this right here is what we need. This right here is what we have. So since we have more oxygen than we need, we can say that our C2H3Br3 is our limiting reactant, and our O2 is our excess. So now we've done the first thing we want to do. We found the limiting reactant. The next thing was how many moles of our excess reactant are going to be left over. Well, that's very simple. We know that we started with 1.25 moles of O2. We know that we're going to use 1.03 moles of O2. And so, at the end, we will have 0.22 moles of oxygen left over. Now we want to find how many moles of each product are going to be formed. So whenever we're finding moles of products formed, we always want to start at our limiting reactant. So we go in and we need to find our moles of our limiting reactant. We know that it's our limiting reactant. We need to find our moles. So we're going to go ahead and do 100 grams of C2H3Br3 multiplied by 1 mole per 266.7 grams, and we see that we have 0.375 moles of C2H3Br3. So next, we're just going to use all of our stoichiometry that we have. We have 0.375 moles of C2H3Br3. And up here, we see that there are, for every 4 moles of C2H3Br3, we have 8 moles of CO2, 6 moles of H2O, and 6 moles of Br2. So we're just going to do each of those ratios. So multiplied by 8 moles of CO2 per 4 moles of C2H3Br3, which gives us 0.750 moles of CO2 formed. Again, we started our moles of limiting reactant, 0.375 moles C2H3Br3, and we know we have 6 moles of H2O per 4 moles of C2H3Br3, which gives us 0.563 moles of H2O. And lastly, we have, again, starting at our moles of limiting reactant, 0.375 moles of C2H3Br3. We have 6 moles of Br2 per 4 mole of C2H3Br3, which will again give us 0.563 moles of Br2. So now we have the moles of each product formed. The last thing we wanted was to find the grams of Br2 formed. So we know we made 0.563 moles of Br2. And we know that the molar mass of Br2 is 159.8 grams of Br2 per 1 mole, which means we formed 90.0 grams of Br2.